This is truly an amazing time for all aspiring front-end developers. There's a variety of courses, educational materials, tutorials, mediums. Seems like endless blog posts and articles sprout like mushrooms after a rain. Many people took this opportunity and successfully taught themselves the craft of front-end development. Surely, most of them quickly began writing features, fixing bugs, architecting their code. After some time, the lucky ones had a chance to see their own features in a live and deployed code. Somewhere on the internet is a web app, a portal, or just a regular website. A truly exciting moment, especially for junior devs. How many of them, or you, ever raised the very important question? We developers create the app, but what magic puts it on the internet? Common thinking is that it's also done by developers, just more senior or educated ones. Some of you might hear of Devops, cloud managers, sysadmins, and other intimidating roles, living closer to some magic realm as opposed to our mortal planet. Well, that's true to some extent. Everything that happens after coding and a successful QA is often associated with the dark arts of scripts, Linux commands, and container-ish black magic. And there is this unwritten law that only the most experienced and trusted developers in the organization are responsible for the successful delivery. Should it be this way? It certainly makes sense. After all, it's a complicated and largely critical task. But does that mean it's a knowledge reserved only to the handful of positions? No, it's not, and I'm here to explain you why. As front-end developers, we could blissfully ignore this aspect and go on believing everything will be done by other magicians. But we shouldn't. The IT world is changing at a great pace, and soon this knowledge will make you more valuable and confident as a developer, regardless of whether you're a front-end or a back-end developer. Writing code is just one piece in the grand scheme of software production and deployment. Let's try to list the steps to ship any product. Let's focus on what happens after the main development phase. Why is it important? Because it can be complicated. Imagine a web-based application with a certain number of features. Let's assume the version release cycle is designed in a way that the app will be deployed to the web periodically, one feature after another. We can assume that every functionality is tested before being shipped to production. Thing is, we probably won't employ just one programmer to do the job. Features will be coded by a team. Those assumptions also imply that apart from every developer's local environment and the final production environment, it's a good idea to have a staging server to push the features into, for testing reasons mainly. Now we're getting closer to the schema like this. As you could see, things are getting complicated, and quickly. Assume that a front-end developer needs a few minutes to build an app. Caring about the code quality, he will need to run linting, run unit tests, integration tests, and possibly other checks before marking their part as done. This takes time. Finally, putting the completed bundle on the server takes another couple of minutes. Now, who wants to take care of manually deploying every single feature? What if there are 5 new features tested every day? And what if there are 50? Depending on the scale, it should certainly take more than one full-time employee just to handle those tasks. This is where the CI/CD process comes into action. Before we talk about software solutions that will build, test, and deploy our code, let's become familiar with those two terms that describe this process. The continuous integration, aka CI, is an idea that covers repeated testing of our app's integrity. From a technical point of view, it means we need to constantly perform linting, run tests, build the code, and so on. And by continuously, it means this must be done during every new code push, automatically. For example, the CI process can define a batch of unit tests that will run with the code. As part of a pull request, every time new code is added, some machine will check whether it meets the standards and contains no errors. The continuous deployment part, the CD, usually covers everything related to the process of deployment and moving the application to the desired environment. also automatically. For instance, it can fetch our app's code from a specific branch like master, build it using the proper tools, Webpack, Babel, and so on, and deploy it to the production, staging, or any other needed environment. Those two terms are separate concepts with the different origins behind the software lifecycle idea. But in practice, they're often complementary processes living in one large ecosystem. Now let's go back to our imaginary project and see how we can use GitHub Actions to kickstart our CI/CD. GitHub Actions is a new tool to perform the CI/CD process. Introduced in October 2018, launched in beta during August 2019, and stable since November. Let's have a look on an open source project which uses GitHub Actions for its CI/CD process. First, we enter the GitHub project and access the Actions tab in order to start editing our workflow files. Here you can see a list of successful and unsuccessful action runs. The default workflow file is called main YAML, which is located in the GitHub workflow directory. We can have different files with different workflows. Each of them will represent an automated flow you wish to perform. The action syntax is based on a YAML declarative configuration syntax. In the previous screenshot, some of you might notice the action store on the right. This is the actions marketplace. Actions are building blocks that power our workflows. A workflow can contain actions created not only by you and your team, but by the community. There are more than 9,000 source actions in the marketplace, and it keeps growing every day. Now, let's check the content of our workflow file. The setup of a workflow file is defined by triggers. It can be a push, a commit, a PR that opened, and so on. You can see the branch we want to execute the action on. The machine we are running on can be Ubuntu, Windows, Mac, or any other common option. One last but not least thing to remember that we have jobs and steps, which are the main core of a workflow file, which are the tasks that we wish to perform eventually. In this case, we are caching our source files. Now, the workflow is set to go. When we upload code to the repository, our workflow will run. It will access the Actions tab of the repository again. We can see runners and the logs output of our workflow steps. When no errors had occurred, we obtain the following. We can also see what happens when an action key input wasn't passed. This is the most basic failure log example. Every workflow run generates a real-time graph that illustrates the running process. You can use this graph to monitor it and debug your workflows. Here you can also see a summary of the action runner. Link directly to the commit which triggered it, displaying a full summary of the workflow's data. GitHub's all-in-one-place agenda allows us to be able to watch the whole CI/CD process fail or succeed directly in your PR and your repository, without using any external tooling or any additional setup. It's important to understand that the resources you get when using GitHub Actions varies according to the plan you are registered in GitHub. The good news is that you can try GitHub Actions for free as a freemium account with limited resources. And the great news, GitHub wants every open source project to be productive. So Actions are free for the 40 million developers on GitHub to use with public repositories. So there are numerous of tools to choose from in order to configure and perform the entire CI/CD process in your app, which you probably heard of, such as Jenkins, Travis CI, Circle CI, TeamCD, and so on and on. So why GitHub Actions? Well, GitHub Actions is a new player in the group of CI/CD tools available to us. Therefore, it's necessary to understand how it evolves against his competitors. There's no need for additional setup or configuration, it comes out of the box with GitHub. We don't have to wait for one job to finish before the second one starts. No webhooks, APIs are needed to set up GitHub Actions. It works on any common runner environment in the market. It has a huge evolving community which produces new actions every day for a plug-and-play experience, and there's no need to switch other screens, connect to any virtual machines, and so on. So the true value of GitHub Actions brings the simplicity and flexibility to all developers. So I'm Rashelle, and I'm a front-end developer in Cloudinary. GitHub Actions changed the way I look on my day-to-day development experience. It provided me the freedom and confidence to deal with the infrastructure aspect of software development without being a Devops, without being a sysadmin, or any other position. So in my free time, you can find me in solving a Sudoku in the closest dogs park with those two dogs. So for more details and information about GitHub Actions, try their documentation. It's amazing. They have an interactive playground, they have great docs, and it's just a wonderful way to kickstart with it. So thanks for your time. Feel free to contact me with those details.